Hello and welcome to our Safety Management System webinar, dedicated to aviation safety across the entire supply chain. From raw material suppliers, component manufacturers, MRO providers, and OEMs, every link in the chain plays a vital role in ensuring the safety and reliability of aircraft worldwide. In fact, safety isn't just a requirement, it's the foundation of everything we do. In this series, we'll explore key topics like the evolution of aviation safety, the regulations behind it, and how it matches with quality assurance, risk management, and the latest innovations shaping aviation safety. Through expert insights and real-world case studies, we'll discuss how supply chain organizations can navigate evolving standards, mitigate risk, and drive a culture of safety from production to final assembly and beyond. If you're part of the aviation supply chain, this webinar series is for you. Join us as we uncover best practices and solutions that help keep the skies safe, one component at a time. This webinar can be found on the IAQG Supply Chain Management Handbook website and its supplemental guidance for suppliers on SMS. The scmh.iaqg.org is the website address, and here under the Plan and Manage section, you can find the SMS content that has been added in April of 2025. The content in the Supply Chain Management Handbook includes three sections. There's an overview of safety management systems and introduces the next two documents. The second document is supplier expectations for product safety within safety management system environments. And the third document is about how QMS, quality management system methods and tools, can be leveraged for safety management system activities or SMS activities. This webinar is set up to start at a high level aviation safety background and work into more details at the supplier level for better comprehension of the need for safety management systems and related expectations in the supply chain. This episode will introduce you to the basics of aviation safety. We'll discuss its evolution through history, how industry reacted to major and minor problems, and where we're going now. Over the past 7 decades, commercial aviation safety has had significant innovations to reduce accident rates. This occurred with a corresponding significant increase in the number of flights being flown. Since the industry must have the highest levels of safety to be successful, and flights will continue to increase, there's a need for continuing improvements. Understanding the past improvements can help us appreciate how future improvements can be achieved. James Reason's Swiss cheese model is often included in accident causation discussions. The concept is accidents seldom occur from a single cause. In most cases, there are several contributing conditions that have to line up perfectly as depicted in the Swiss cheese model diagram. As we review historical accidents, you can think about this accident causation model and what it means to how we can achieve future safety improvements. In the history of aviation, progress can be divided into 3 main eras of activity, each with its specific approaches. Andrea, Suzanne, and Tom, could you help us better understand what these phases are?
Of course, David. From the safety standpoint, the first decades of aviation are called the technical era. In fact, from the early 1900s until the late 1960s, aviation emerged as a form of mass transport. Of course, there were deficiencies, failures, and accidents, but they were mostly related to technical failures. Just consider the technology available at the dawn of the aviation compared with today's standards. Therefore, focus was initially placed on the improvement of the technology of the aircraft. Improvement in design and manufacturing, reliability of the components, and the use of automation produced safer aircrafts. By the 1960s, these technological improvements gradually reduced the frequency of accidents. A couple of notable examples can better explain this leap forward.
Yeah, in the 1950s, a company called de Havilland started developing the first commercial jet airliner, the Comet. The new aircraft was faster than its propeller-driven, piston engine-powered competitors, and it could fly higher. Because of that, the fuselage was pressurized. However, the construction technology de Havilland used was that of the preceding aircraft. There was limited understanding of the effects of altitude pressure changes on aircraft structures, particularly on the square-shaped windows. The pressurization cycles caused fatigue and cracks in the fuselage. This led to 3 aircraft breaking up in flight between 1953 and 1955. The subsequent investigation led to significant changes in aircraft design and improvements in aviation safety.
Suzanne, another notable example of technical improvements can be found in the investigation report of the TWA Flight 800 accident that you see noted on the right. Although we are slightly after the said milestone of the 1960s, the technical improvements never did stop. In fact, in 1996, the TWA Flight 800 exploded midair just after takeoff from New York to JFK Airport. The most likely root cause of the explosion was a short circuit in the fuel quantity indicating system. The short circuit generated a spark from a damaged wire that ignited the fuel vapors in the center tank. And after the investigation, the industry developed the Electrical Wiring Interconnect System, or EWIS, an acronym to indicate the dedicated maintenance procedures to the electrical system and better fuel tank design to avoid the buildup of fuel vapors. So I think we're coming to the human factors era on slide 9.
Yes, thank you, Tom, and thanks for these examples. But we said the aviation safety went through different stages. What was the next step in this journey?
Well, David, the next step in aviation safety is in fact the human factors era. By the early 1970s, thanks to the continuing technological improvement, aviation became a safer mode of transportation. However, accidents still happened. Indeed, it emerged that many accidents were caused, among others, by poor human performance under certain circumstances. So the focus of safety management was extended to address human factors and the man-machine interface. The human performance was studied to understand the causes of the errors. Training was improved to avoid the reoccurrence of mistakes, and human factors management was introduced. Let's see how this was achieved.
Yeah, the first and foremost accident which highlighted the importance of studying human factors is the Tenerife airport disaster, the worst single accident in the history of civil aviation. In 1977, in foggy conditions, 2 aircraft collided on the runway. Among the causes of the pilots' errors, miscommunication and poor language standardization contributed to the general lack of situational awareness by the pilots. Also, the stress under which the crews were operating and the pressure that one of the 2 captains put into the takeoff contributed to the accident.
Also, it's worth discussing the causes of the accident that occurred on an Eastern Airlines Flight 401 in 1972, as depicted on the right here. This was a commercial flight from New York to Miami, and during the approach to destination, the flight crew noted a malfunction in the nose landing gear indicating light. Instead of splitting their duties to address the problem while continuing to fly the airplane, the pilots focused on the troubleshooting of the problem, unaware that the autopilot had been inadvertently disconnected. As a result, the plane gradually descended without the crew noticing, eventually crashing into the Everglades. The investigation revealed that the distraction and the poor workload management and duties assigned, along with the weak visual and oral warning in the cockpit, contributed to this accident.
Yeah, Tom, indeed, better training and cockpit ergonomics were introduced to avoid such circumstances. Nevertheless, despite the improvements, human factors tended to focus on the individual without fully considering the operational and the organizational context.
Andrea, can you tell us more about that?
Well, of course, David. It was not until the 1990s that it was fully acknowledged that individuals operate in a complex environment that include multiple factors which could affect the performance. From then on, safety began to be viewed as a systemic perspective and began encompassing organizational factors as well as human and technical factors. This perspective allows us to intercept such things as poor organizational culture and bad policies, which most often generate latent causes of the accidents. To mitigate such latent threats, routine safety data collection and analysis enable the organization to monitor known safety risks and detect emergency safety trends. These enhancements provided the learning and foundation which lead to the current safety management system approach. In fact, this is reflected in what the investigations discovered beyond the immediate causes of the accidents.
Yeah, Andrea, just think about what caused the American Flight 191 crash in 1979 because of the detachment of an engine from the wing. The accident was caused by major breakdowns in both the operator's maintenance organization and the aircraft's manufacturer. In fact, the manufacturer implemented an upgrade of a component inside the engine pylons along with instructions. These instructions for the upgrade required a lengthy procedure, with the maintenance organization perceived as a waste of time and resources. They instead developed their internal alternative procedure without manufacturer coordination to speed up the maintenance cycle. In doing so, they failed to realize the incremental damage, generating using a forklift to lift the engine pylon assembly. Over time, this became a norm for the accomplishment of the upgrade. The alternate procedure generated fatigue cracks on the pylon, which caused the accident months after the actual maintenance.
Another example of how organizations play a pivotal role in the chain of events leading to an accident is the crash of the Swiss Air Flight 111 in 1998, as depicted on the right diagram. During a flight between New York and Geneva, the aircraft suffered a fire in the cockpit started by a faulty wiring from an in-flight entertainment system addition and insulation design that was found to be inadequate. Several latent causes were highlighted. First, the in-flight entertainment system wiring was not properly coordinated in the certification process. Second, the maintenance oversight did not detect the faulty wiring. The flight crew was unable to deactivate the proper electrical in-flight entertainment system due to the lack of information. Finally, it was highlighted that there were regulatory oversight and certification gaps. The aircraft's design and the absence of adequate emergency systems to deal with such situations contributed to the fire spread.
Yeah, as you can see, the complexity of accident causation is increasing, and the need for more advanced tools to allow us to address the increase in causal factors in complex systems. Therefore, the SMS is seen as the next step in this improvement. So today we are addressing the aviation safety considering the organizations which forms the industry. Also, from the beginning of the 21st century, many states and service providers had embraced the safety approaches of the past and evolved to a higher level of safety maturity. Reckoning that the complexity of the aviation systems and the management of the interactions between different organizations all play a part in aviation safety is leading to the so-called total system era. This is how the whole industry must evolve. In particular, the management of the interactions between the different organizations of the aviation system can bring benefits to the safety management overall. This shall include the OEM's supply chain, which can introduce latent hazardous conditions. Therefore, suppliers have to raise their awareness on safety matters to intercept possible threats as early as possible in the potential chain of event of an accident.
All right, very good. Thank you, Andrea, Tom, and Suzanne for those insights. Some takeaways. Aviation industry must have the highest levels of safety. Flight volume continues to increase, and therefore, for us to improve the time between accidents, to eliminate accidents as much as possible, we need to continue to improve. Advancements in aviation safety have occurred to technology, human factors, and organizational management enhancements. And safety management systems, or SMS, is our next evolution, part of the next evolution for safety improvement. So thank you for your participation. We hope you found this valuable and will join us for the next session that further explores safety management systems and SMS. We'd like to thank IAQG, Supply Chain Management Handbook, SMS Writing Team, and the IAQG Communication Team, which have given us the opportunity to share this information with you. Thank you.